So today's topic is linked list. So before going to that, we will see what is array that we have already seen in the beginning of last module. Also, we have studied in the last semester also, but still just a brief idea and why we need a linked list. So in order to understand the importance of linked list or the necessity of linked list, we should know what is the problem with arrays. So arrays are used to store multiple data items of same type using a single name. And elements are, we know the example. So if I have an array with a name A, then we have multiple data items. Say I store 10, 20, 30, 40. So there are 4 data items here. They are accessed using one single name, and the name here is A. And what how we can randomly access any item. So how we randomly access? So if I want to access, by means of A of I, or like A of 0th item. So if I want to access the third item, I have A of 3. Third item means 0, 1, 2, 3. Or third one, it will be the 4th one in the actual sequence because our index starts with 0. And what about the memory? Memory is continuous location. So in the actual memory, we will be storing this A of 0, A of 1, A of 2, these 4 values. So since the size of this array is 4, all these values will be in continuous locations. In memory. Okay. So this everybody knows by this time. Okay, so what are the disadvantages of such an organization? So from the lab experiments you may be knowing. So you might have set the array size as 20 or 30. So for quicksort or merge or whatever programs we have already done using arrays. So if I want to sort 50 elements and if your array size is 20, then that is not possible because already it is a static allocation. ഒരിക്കൽ allocate ചെയ്ത് കഴിഞ്ഞാൽ ഫിക്സഡ് ആണ്, നമുക്കതിനെ സൈസ് ഒന്നും ചേഞ്ച് ചെയ്യാൻ പറ്റില്ല. So we'll see. So that is the first one. Not possible to allocate extra memory. So once we fix it as 4 locations, A of 4, we declared it A of 4. It's not possible to make it 5, or it's not possible to make lesser. So resizing is also not possible. That is, suppose I declared something like int A of 1000, but actually I need only 5 elements. So what happens? 995 space wasted. It is not available for other purpose because this is exclusively reserved for this. But then it is the other space is wasted. Okay, so resizing is not possible and requires continuous memory location. So suppose we have the memory. This is memory. Suppose we have some data here and some data here. So we may not store the data continuous. So suppose I have declared int A, B, I, J, K. So if I declare like this in C program, this need not be continuous location. A can be here, I can be here, then J can be here, then K can be here. It need not be continuous. Whereas if I declare something like int X of 5, then that will be continuous 5 location. So that's X. So from this we can understand. So already we have reserved some space for all. This memory belongs to what type of memory? In the last class we told there is code memory, then stack memory or global space, then we have heap space. So all these are in stack. stack space in the memory is a fixed space. So if we have already allocated many spaces for different variables, and if I want to allocate an array, and if the size of the array is say 1 lakh, and if there is no continuous 1 lakh locations are available, then in that case it is a serious problem, because array creation is not possible, because it requires continuous memory location. Sometimes we may have total 1 lakh spaces available here and there all together in the memory, but if continuously 1 lakh spaces are not available, then we cannot use that array, or we cannot make use of that one. So that is the issue with array. Then another issue, maximum number of elements to be stored. The size of the array should be known in advance. In advance means not before execution. When we write the program itself, we should know. So before compiling, we should know what will be the maximum size. So once we fix that, while running the program, we can use only part of that array, but we cannot. So if I have declared 50 is the size, then if I use only 20, then it's okay. But in that case, 30 spaces are wasted. But if I declared 50 and I need 100, then it is difficult. So for example, for a class, we have 60 students, and we declare the size for processing the student information with array 60. But if I admit 6 students as lateral entry and it becomes 66, then it is difficult, because in the program we have declared only 60. So it cannot accommodate not more than. So these are some issues or array. So I think I didn't provide the title. So disadvantages of array. Okay. So it will be better if we have dynamic memory allocation. നമുക്ക് ആവശ്യത്തിനനുസരിച്ച് മെമ്മറി അലോക്കേറ്റ് ചെയ്യാം. ഫ്രീ സ്പേസ് എവിടേക്കാണെങ്കിൽ അവിടത്തേക്ക് എടുത്ത് ഒരുമിച്ച് ആക്സസ് ചെയ്യാൻ പറ്റും. അങ്ങനെയൊക്കെയുള്ള ഒരു മെക്കാനിസം ഉണ്ടെങ്കിൽ ഇറ്റ് വിൽ ബി വെരി മച്ച് റെലവൻറ്റ് ഓർ ഇമ്പോർട്ടൻറ്റ്. സോ ഫ്രം ദീസ് തിങ്സ് യു നോ. ആൻഡ് അഡ്വാൻസ് ആയിട്ട് അറിയേണ്ട കാര്യമില്ല എത്ര സൈസ് വേണമെന്നുള്ളത്. ആ പ്രോഗ്രാം സമയത്ത് നമുക്ക് എത്ര എലമെന്റ്സിന് ഇൻസെർട്ട് ചെയ്യണോ അപ്പൊ അത്രയും സൈസ് അലോക്കേറ്റ് ചെയ്യാം. എത്ര എണ്ണത്തിന് ഡിലീറ്റ് ചെയ്യണോ അപ്പൊ അത്രയും സൈസ് ഡി അലോക്കേറ്റ് ചെയ്ത് കളയാം. ആൻഡ് കണ്ടിന്യൂസ് ആയിട്ടില്ലെങ്കിലും കുഴപ്പമില്ല, ഡൈനാമിക് ആയിട്ട് നമുക്ക് എവിടെയാണ് ഫ്രീ ഉള്ളത് അവിടെ നിന്ന് എടുത്ത് അങ്ങനെയുള്ള ഒരു ഡാറ്റ സ്ട്രക്ചർ ഉണ്ടെങ്കിൽ then it was very much useful for us. So that is the all about disadvantages of arrays. So now we go to linked list. So linked list is such a dynamic data structure. Compared with array, it is not static, so it is a dynamic data structure. So I have a small definition. A linked list is a linear collection. So these are the main points. So linear collection. Array is a linear collection. So that is from here itself, you know, array is linear. Linear means in sequence, 1, 2, 3, 4, like that, in or some order. There is some order of elements. First element, second element, third element, fourth element. In that way we can access. Or we can say, or even if we are not accessing in that sense, we can say this is the first element, this is the second element. There is a linear order. So compared with the array, the linked list is also a linear collection, and it's a collection of homogeneous. You know, homogeneous means same type. Homogeneous, same type. Array is a collection of a same type. So linked list is a linear collection of homogeneous data elements. So it is the same type. Array is also homogeneous or same type. But what is the difference? So I told it is linear collection. So it is like array. It is a linear order and it is homogeneous. It can contain a collection of same types only. But there is the difference is these collection of data elements, and each data elements are called nodes, and each nodes are connected by means of a pointer. That is the difference. So it's a collection of homogeneous elements, and it is a linear collection, but each elements are connected by means of a pointer. അപ്പോൾ പോയിന്റർ വെച്ച് കണക്ട് ചെയ്യുമ്പോൾ പ്രത്യേകത എന്താ? ഈ എലമെന്റ്സ് അടുത്തടുത്തുള്ള ലൊക്കേഷനിൽ വേണമെന്നില്ല. That is the main advantage. So since in array we don't have a pointer, So we store continuously 1, 2, 3, 4. But here what I told, this is array, and linked list means this is a collection. So of 4 4 elements. It's a collection, but it need not be continuous. So how we connect this in the order? So we connect using some pointers. And from there, no pointers. So this is a linked list. But why it is called linear? Because we can go in a sequence from 1. We follow this link and reach second position, and we follow this link, we reach third position, and follow this link, we reach 4. So there is a linear order. In an array, we start with a of 0, then 1, 2, 3, so then we'll get 1, 2, 3, 4. So it's a linear, and it's a collection of same type elements. So here it's all integer elements, but they are connected by means of pointer. So they need not be continuous location. It has a different location. So a node has 2 components. So each element, this is called a node. So we can say this is node 1 or node 0, whatever, no problem. Because here there is no index. So we can say 1, 2, 3, node 3, node 4. So a node has 2 components. What are the 2 components? One is data. That is the value which we store. And we have a next pointer, and some textbooks say next or link. Next pointer or link. That is pointer to another node. And linked list is a dynamic data structure. Dynamic data structure. So amount of memory can be easily varied during execution time. So if I need one more element, I create a pointer from here and I allocate another one here and just connect it. So we will see the insertion and deletion later. So I'm not explaining the algorithm here. So it is possible. So it's all implemented using pointers. So if I cut the pointer from here, then the list is split and I can delete those things. That is possible. Okay. So before this, I forgot to mention or explain one point. Insertion and deletion are relatively expensive operation in array. What is expensive? Expensive means it takes more time or more operations. Why it is like that? Suppose we have an array. So expensive means more time or more space. That is expensive. But time and space both are precious. So that is what expensive. Computer science expensive mainly it takes more time to execute or it needs more storage. For why it's more? Because array have a continuous location. So for example, if I want to insert an element here, what is needed? I need to shift this 30 and 40, then make a space here and insert there like that. That's how only we can insert. So suppose we have 1000 elements and I need to insert a new element at a 500 position, then remaining 500 elements should be shifted one. So 500 steps of operation is needed. So that is why it's like, and suppose in the worst case, if I have an array of size 1 lakh and I am going to insert an element at the second position, then all the remaining elements except the first in the 1 lakh elements need to be shifted. So that is why it's expensive. So I forgot to mention this earlier. Okay. So here it is dynamic data structure. So amount of memory can be easily varied. So we will see how we can easily vary by just manipulating these pointers here and there. So we can easily vary. We can allocate and deallocate easily. So we can insert in the between easily. There is no need to shift all those. Just manipulating 2 pointers, we can easily insert anywhere. So we will see those algorithms later. Maybe in the next class only we will be discussing more algorithm. So what is a node in the linked list? So we told already a node in the a node in the linked list has 2 components. So one is data and another is next pointer. Next is a pointer. This is a general structure of that node. So if you remember the previous class, you may get an idea how this can be created in C program. So it will be using a structure with the two components. One is a data component, another is pointer. And what is this pointer? This pointer is pointer to another node. That is important thing. So that will be the same type. So it is a self-referential structure. So we need we will see the declaration later, a self-referential structure for creating a node. So that we will be seeing while we discuss the algorithm, the general structure. So if you carefully observe this and you are aware of the previous class topic, then you will easily get the idea why we need a self-referential structure. What is self-referential structure? A self-referential structure is a structure which has a pointer to itself. One or more pointers. So this is only one pointer. Okay. So a linked list, coming to what is linked list, is called linked because each node in the series has a pointer that points to the next node. All elements in the link established in it is called a linked list. So a linked list is called a link because each node in the series has a pointer that points to the next node in the list. But normally array we access by a name. Array has a common name, but linked list does not have a name because compile time program linked list declare so we cannot give the name implicitly. So this linked list is called A or this linked list is called B. That is not possible. So does not have a name. So how we access? We keep a pointer. So how we access how we access a list? That is we use a pointer. So that is the pointer called a head. So a head pointer. So we create a head pointer, and whenever we create a new linked list, then we make this head pointer point to the first node in the list. So this head pointer. So head can be either head can be a pointer. Pointer means it's a type node type pointer, or it can be a node itself with no data. That's what mentioned here. So in some books they use just a pointer of node type only head. Otherwise we use node with no data. So in our algorithms we will be using this method. Does not have data content, and next pointer contains the address of first node in the list. That is, so suppose this is the linked list, and this element 1, and there we have element 2 and 3, and 1. This is connected to this next pointer. So this node's next pointer points to this third node, and third node there are no more elements, so we will have null. Null means it is not pointing to anywhere. So once we reach the null, or we see that the next pointer is null, that means the list is over. That is how we find what is the end of the list. In array, when we reach the size of the array, then the array is over. That is how we find the array is over. But here how we find, because there is no size, nothing like that. We don't keep track what is the size, but instead we keep track of where is the beginning. So now we need a head. So head will have no data contents, but it have a pointer that points to the first element. So this is the first node. So it will point to the first node. And once we start with the head, we get the first node. If I get the first node has the pointer to the next node. So I can go to the next node. Then if I get the next second node, it has pointer to the third node. So I can go to the third node. Then it has no pointer, it is null. That means we are reached the end of the list. This is how we go through the linked list. Okay. So now, what are the different types of linked lists? So depending on number of pointers, number and nature of pointers, we can say. That is single linked list. The single linked list has only one pointer. ഒരു നോഡിൽ ഒരു പോയിന്റർ മാത്രമുള്ളതാണ് single linked list. Whereas double linked list, each node has 2 pointers. And what about circular linked list? Circular linked list can be a single linked list, or it can be single or double. But the idea is last node connected to the first node. Here in our previous example, you can see we have the pointer to the first node, then we can reach till the end. Once we reach the end, if I want to go to the beginning, again we start with here. Or if I want to access the second node, that is not possible. We cannot come back from here. That is the idea. So those things are difficult in a single linked list. So we have a circular and double for overcoming those things. So if I simply draw these things, we'll draw single linked list. We have already drawn. The structure is like this. Okay, and this represent. So null, this represent null. Some people make or like this, or maybe some like grounding in electronic circuits, or that's also null. And okay, you can represent it, so it's null. So what about the double linked list? Double linked list have each node has 2 pointers. One pointer to the forward direction and one pointer to the backward direction. And the first node will not have backward direction, and the last node will not have forward direction. This is how a double linked list. What about the circular linked list? Circular linked list will take circular single linked list. The last pointer will point to the first node. And for all these things, we'll have a head, so that I am not drawn here. So that we will discuss when we have algorithm. So this is just a structure. So these are the 3 types of linked list. Single linked list, each node has only 1 pointer. And double linked list, each node has 2 pointers. And in circular linked list, the last node connected to the first node. Okay. So first we will discuss single list. So we may not complete single linked list today. We will have start off with the topic, and some algorithms we will discuss only tomorrow. Okay. We don't have that much time today. So single linked list. So once single linked list is clear, then it's easy to understand how double linked list or circular linked list is done. So like we have simple queue, then circular queue, then we had double-ended queue, like that. So if once circular queue is done, then double-ended queue is simple, because just 2 functions only modification, and remaining functions similar manner. That's why in last lab, so altogether we have given 3 programs: simple queue, circular queue, and double-ended queue. So once you implement a simple queue, then it's easy to implement circular queue. So if you have properly implemented simple queue, then there is slight change in the NQ and DQ, then it's circular queue. Or then once we do circular queue, same program, if you modify a little bit, that is adding 2 more functions inserting and deleting at the other ends. So then it will be double-ended queue. So if you properly write one program, then it's easy to do second and third program. So it will not take much time. So if you are not properly doing the first program, then it's difficult. So okay, leave it. So okay, single linked list. So single linked list grows in only one direction. That is a forward direction or forward or left to right. ഇതിപ്പോൾ നമ്മൾ ലോജിക്കലി പറയുമ്പോഴാണ് ലെഫ്റ്റ് ടു റൈറ്റ്. ആക്ച്വലി മെമ്മറിയിൽ ദിസ് ക്യാൻ ബി എനിവെയർ. സോ ദിസ് ലെഫ്റ്റ് ആൻഡ് റൈറ്റ് ഡസ് നോട്ട് മീൻ. ആക്ച്വൽ മെമ്മറി ഇഫ് യു സി, so first node may be here, second node may be here, third node may logically ആണ് നമ്മൾ forward and say first node can be here, second node here, third node here, fourth node here, say fifth node here, sixth node here. ഇതിങ്ങനെയൊക്കെയാണ് മെമ്മറിയിൽ. No left to right or top to bottom ആവണമെന്നില്ല. So that doesn't matter. Actual memory. So okay. Okay. So what I say forward direction or left to right, that means it's logically when we visualize it is from left to right. That's all. Okay. Each node contains only one link. That is single linked list, which points to next node in the list, points to subsequent nodes in the list, and header node points to the first node in the list. So these are all clear. And link field or next field. Some people say link field or next pointer or whatever it is. It's contain null value of last node contain null value that we already told. Here one can move from left to right only. So this left to right, what I told, it's logical. So it is also called one-way list. If I want to come reverse, so if I want to print 1, 2, 3, it is easy. Start from head, then we'll print 1, 2, 3, then 3 null. So if I want to print 3 to 1, it is difficult because there is no way to come back to 2 from 3. But in the case of array, I can randomly access A of 0, A of 1, A of 2, or I can access A of 2, A of 1, A of 0, any order, no problem. But here, that is not possible. That is very difficult. So that is the specialty of single linked list. Now, how we represent linked list in memory? Representation of linked list in memory. Okay. There are two methods. First one is static representation, that is using in array intent. So that may not be efficient because again, we may have wastage of space and all, but still we see how we can represent a linked list using arrays only. Then we have dynamic representation, that is using free pool storage, or free pool storage means the heap. What is this? Heap. From heap, dynamically take a memory and we use. That's the idea. So first we will see static representation using array. So for the static representation, there are two arrays, one for storing the data elements and another one for storing the pointers or link. So suppose this is the array header, from header or head. So some people call header or some header, whatever it's not. That means the pointer to the first one. So header has the data part empty and points to the first node. So this list has 6 nodes named N1, N2, N3, N4, N5, N6. So in practice, when we do program, we don't have names for each nodes. Please remember that we don't have names for each node. This is just for reference. The picture we have told it's N1, first node, second node, etc. We cannot access it as N1, print N1 dot data, N2 dot data. That is not possible because we are not doing that manner in program. So we may be going with a dynamic representation. This is not static representation. This is a linked list. So we will see now how we will represent statically. Don't misunderstand. This is static representation. No, this is the linked list. On the next slide, we will see how we statically represent using two arrays. There will be two arrays, one for storing data. So which are the data here? 59, 38, 64, 14, 72, 80. So these are the data. So in the memory, this data may not be stored in continuous location. That is the difference with respect to array. So what was the first element? First element was 59. So 59 is stored here. So this is the first element. So how we keep track of the first element? We keep a header. So header stores the address of this. So we have given the address also here for, so 44 the address of this location. So header keeps that 44. Then we keep another array. So this is an array data and this is an array link. There are two arrays. So this is memory location. This is array of pointers. So this data, this is our memory address 41, 42, etc. Memory address, not values. And this is array of pointers. Then what we will do, this data arrays corresponding position. So this is data of 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, in this place, link also it is 0, 1. There is a symmetric connection. Nine. Okay. So where is the first element? It is a data of 3. So the link of 3 will contain pointer to the next node. So that is 41. That means next element is at location 41, that is 38. So you see here, after 59, next element is 38. Then where is the third element? That pointer will be here. So 38 is at data of 0. So we see what is at link of 0, that is 50. So 50 means it is location here. 50 is this. Okay. Then that's clear. Then from 50, the value is 64. The third node is 64. Then from there, where is the pointer? It is to 14. So we see what is 64, ninth element. So ninth element has link 43. So 43 has value 14. So I think now it is clear. There is no need to tell the complete thing. And what is the last element? Last element is 72. And the value 72, you see, it is at data of 6. And we see what is link of, sorry, not last element is not 72, last element is 80. So for 72, link of 6 is 45. So 45 location 80. And what is the link of this? That is null. So that means 80 is the last element. So what are the elements in this sequence? First element is given by header. So header points to 59, and 59 we see what is the pointer 41. So in that 41, what is the value? 38. And for corresponding to 38, what is the pointer? 50. So at 50, what is the value? 64. Then at 60, corresponding to 64, what is there? 43. So at 43, what is the value? 14. Corresponding to 14, the pointer is 47. At 47, what is the value? 72. And 72 points to 45. That 45th location, it is 80. And 80, the pointer for that is null. So we have null. So now you go understood how we represent a linked list using static array-based representation. So this representation has all the advantages, and this is not all the most of the advantages of linked list and all the disadvantages of array, because this is static. So if I allocate data of size 100 and link of size 100, then we can store maximum 100 elements. That disadvantage is still there. But these elements need not be stored continuously. That is the advantage. So the expensive, that disadvantage of array, that is, if I want to insert somewhere in between in the list, suppose I want to insert here as something 93, what I need to do? I need to check 64's pointer, 64. So I can insert 93 somewhere here. Then what is they say that pointer is 60. So for this 64, this pointer I'll change to 60, and this 93 pointer I change to 14. So where is 14? 43. So I will make to 43. Like that. So that is the idea. Okay, so insertion, so there is no need to shift. So wherever there is some vacant space, I can allocate. So that advantage is here. So, and we can, the locations are not continuous, that is advantage, but overall size is limited. That is a disadvantage. So static, since it is static allocation, there is definitely some disadvantage. So actually what we need is dynamic allocation. So dynamic representation. So last class we have seen the dynamic memory allocation. So that type of allocation. So now we go for dynamic representation of linked list. So the efficient way of representing a linked list is using free pool storage or the whatever free memory available. So that is a heap memory. So we have memory bank, that is heap. Memory bank is a collection of free memory space. Memory bank is nothing but collection of free memory. And we need have a memory manager. So that is the component of operating system or Ubuntu or Windows, whatever operating system we use. There we have some memory manager component. So in the coming semesters, we will see or study the course operating system. The major functions of operating systems are memory management, program or process management, storage management, all those things we'll study then. So what is the function of memory manager? So whenever we need an extra element to be stored, we need to create a new node. This will see where any memory available free. So that will be allotted. So the memory manager is for allocating and deallocating from free memory from the pool. So whenever we need a node, the request is placed to the memory manager. So that is what happens malloc. So when we do a malloc, actually request go to a memory manager, it allocates from the free memory and the pointer to the at is returned. It will search the memory bank. So if there is a block free, then it will be granted. If there is no block free, then null pointer will be returned. That means no memory available. So whenever you do programs for the lab, that situation will not come because we have enough memory and we will be experimenting with maybe 10 or 20 or 50 elements. So it will not get exhausted. Then the next, the deallocation part of memory manager, that is done by garbage collector. Garbage collector is a program that returns the unused node to the memory bank. So when we allow free memory which is not needed, or once it is deleted, then that is again going back to the free pool. So this is the idea. So this is the memory pool. Memory bank, that is available memory. And we already have a list like this. Okay. So if I want to have a new node XY, then we allocate using some, say, malloc. So then we'll get this particular block from the memory, and that is a new node. Then what we need to make the last pointer of this linked list to this node. And so what happens? That comes here. And this is removed from the available memory. How we make it? This is removed. So available memory is again a sequence. So this place is available. Afterwards, this is available. This is available. This is available. Afterwards, this was available, but now it is used for this linked list. So what happens? After this pointer changed to here. That means effectively this is removed. I'll say. Effectively it is removed and it is placed here. That's the idea. So I'll undo that. Then you got the idea. Okay, so that is about the dynamic representation. So next is operations on single linked list. So we have these operations. So we need to discuss the algorithms. These algorithms are simple. So if you understood the concept so far, then it will be easy. So those algorithms we will discuss in the next class. So we will stop here. Okay, thank you all.
Sir,
Huh?